first rock group we're going to talk about are the igneous rocks. I have two pictures here that show two very different kinds of igneous rocks. One of them is coming out of a volcano, and this is one kind of igneous rock. The other one over here is Half Dome from Yosemite National Park. And these rocks did not come out of a volcano, but they did form from molten material. And that's why they're both considered igneous rocks. Here are the Unit 6A learning outcomes. Go ahead and pause the video and write these down. There are two locations where igneous rocks form. One of them is above ground, and this is known as the extrusive realm. The rocks that form in this realm are called extrusive or volcanic. The other rocks form where magma chambers cool and solidify deep below the Earth's surface. This is known as the intrusive realm or the plutonic realm. In mythology, Pluto was the god of the underworld. This is where the rocks from Yosemite formed, and they were later uplifted by plate tectonic processes. So these are two big divisions when it comes to igneous rocks, the plutonic rocks and the volcanic rocks. It's pretty obvious that volcanic rocks form from molten material. We can see volcanoes erupt. We can see lava flow over the Earth's surface. We can see that it's hot, molten, and that it cools and forms rocks. It wasn't quite as obvious how plutonic rocks formed or that they formed from magma. So there were several lines of evidence that led geologists to realize that they were also forming by igneous processes. Here's an example of some granite, which is an igneous rock, that formed when magma moved into some cracks and crevices in a pre-existing rock. So the rock that has this brown color and stripy appearance is a metamorphic rock, and after that metamorphic rock formed, it was intruded by magma that then cooled and became this granite. That's the white color. So geologists looked at that granite and they found three lines of evidence that it formed from hot molten material. The first line of evidence was that it was made of interlocking crystals, just like volcanic rocks. There was no cement holding the crystals together, and although we have not talked about sedimentary rocks yet, sedimentary rocks tend to be made of material that's held together by a cement. So there was no evidence that granite had a sedimentary origin. If you look at the way that the granite in this particular picture seems to have filled cracks and crevices, it makes it look like it was a fluid that filled in wherever there was an opportunity for it to ooze into areas of weakness. So that was a second line of evidence, that it seemed to have filled fractures as if it were a liquid. A third line of evidence was what we call baked zones. And these you would have to look very closely for. But along the margins where this igneous material intruded, there's evidence for a baked zone where it contacted the colder rock. And that's because the very hot magma basically baked the margins where it intruded and caused some changes in the mineralogy. So all of these suggested that the material that was intruding was in fact from hot molten material. So for those of you who picked up a PCC rock kit, if you haven't opened it up yet, you should do that. And what you'll find are 4 baggies of rocks and then 2 minerals that are kind of floating around there by themselves. Now the baggies of rocks are actually separated based on rock type. And if you look closely, you'll see that the rocks are labeled. This bag right here has 2 labels, and I've blown that up in this picture. And you can see I-17 and I-7. They're kind of upside down. And the I stands for igneous. So this is the first bag that we're going to use. If we look at this bag over here, I blew that up over here. And we have an S25 and an S1, so those are sedimentary rocks. There's another bag with another set of S rocks. And then there's a bag with M labeled rocks for metamorphic. So we have the metamorphic and sedimentary rocks here, and you can put them to the side until we get to those. These two things right here are actually minerals, and they're very common rock-forming minerals. They are quartz and orthoclase feldspar, and we're going to look at these quite a bit throughout the rest of the semester because these are very common in all kinds of rocks. So you've been given those just so you can have a look at those close up and firsthand. But for now, we're going to work with the igneous rocks, and you're going to be looking at them in lab. So if you take them out, you'll see that there are only 9 igneous rocks, but they're labeled in a rather odd way. We've got an I1, an I4, an I7, an I23, and that's because in the igneous rock lab there are 24 rocks, and we've only given you 9, but we've matched the numbers up so that this I1 matches the I1 in the rock lab, this I7 matches the I7 in the rock lab, so that's why they're numbered that way. Now, I'm not going to have you do anything right now with these rocks, although I do want you to notice these two right here, and I'm going to show you a blow up, I10 and I17. These rocks are very different in their texture, and texture in geology means the size of the minerals. I10 has a fine-grained texture, meaning we can't really see the minerals. There are some there, but they're very tiny. The other one, I17, has a coarse-grained texture. We can see dark black minerals, white minerals. There's actually 2 different kinds of light-colored minerals. Some are glassy and some are more white. And so what this tells us is that because the minerals in I10 are small, there was not a lot of time for those minerals to grow large. So this rock cooled quickly, which means it's an extrusive rock. It formed from a volcano. The lava came out on the surface of the earth and it cooled quickly. On the other hand, the minerals in this rock had a lot of time to grow large. So this rock cooled slowly. We call it intrusive. This could be the rock that made up Half Dome at Yosemite. So when you're looking at your rocks, you will want to use a hand lens like this. And you take your rock, here's the I17, and what you want to do is you don't want to do this, because that's not going to help you at all. You want to take the hand lens and you want to put it right up to your eye. If you wear glasses, you could put it right up to your glasses, or you could take your glasses off. And you want to bring the rock right up to focus. And then you can see a lot of detail. Now, of course, this one, there are very large minerals in there that I can see pretty well even without the hand lens. But this one, I10, I really need this hand lens to see it. And I'll show you how you would do this without glasses. You just bring it right up to your eye. And now I can see little rock fragments because this is a volcanic rock. So sometimes little fragments of rock are mixed in with the lava when it erupts from the volcano. And I can see little crystals of quartz. I can also see little pieces of pumice. So that's what we're going to be doing when we look at our rocks this semester. Coming up next, there are 3 videos that you're going to watch. A very short 5-minute one called What Are Igneous Rocks? It's a good introduction to igneous rocks. Then this video, which you already watched for a homework assignment, but it's good to watch it again and maybe take notes if you didn't. And then finally, a video about plutons. What do we call the various igneous intrusive bodies that intrude below the surface of the earth?